Hello, my name is Nicholas Montecrusos,
And my name's Ryan Vine.
and our final project is on HSMXpress, which is a CAM add-on package for SolidWorks. So a little bit about that. Oftentimes when you're modeling things, the ultimate intent is to realize these parts and to manufacture them. And when it comes to machine parts, a very popular way to do this in this day and age is through CNC machinery. In other words, automated machine tools.
HSMXpress allows you to plug in the program straight into SolidWorks so that you can do the CAM work straight within the SolidWorks interface. You can see that right here. This is a part that we made previously for this demonstration, and we've already run all the tool paths on it. So just as a demonstration here, you can see all the tool paths. I'll shut those off just so we can see this a little bit better, and then hit play, and you can watch as the program controls the CNC machine how the part would come out as a finished product. So it's pretty cool what it can do, and it's really quite powerful. So again, HSM is a free software plugin for SolidWorks that you can get from hsmworks.com. HSMXpress is their free version. It's the 2.5D CNC programming software. If you want to go all out, you can get the HSM Works, which is a paid-for program that does 3D CAM capabilities.
Alright, so you may be wondering at this point, what exactly is 2.5D machining? Well, what that means is that you can essentially machine things that are on an XY plane, on a two-dimensional plane, that have a depth associated with them. So the picture that you're seeing on the screen right now, that's a perfect example of a 2.5D machining process. So as you can see, all these contours can be drawn on a plane, and there's just simply a depth that's associated with them. A 3D machining solution would be something that essentially is a true generated surface that can't be modeled on an XY plane, such as this bottle right here.
So to get going in this software, we already have our part modeled, as you can see right here, and we created an assembly file that has the Kurt vise, which we will be using on the CNC machine, and we also have parallels in here. And that'll just help us see what's actually going on and how it's actually going to happen when we CNC this out on a CNC machine. So you can go, the first step is to go in here and click job. We already have one set up, so I'm just going to edit this. There we go. And you can see the first thing that comes up is the model here. And so I have selected our part model that we will be CNCing in this project.
Alright, so an important aspect of this is obviously when you're going to machine something, you have to start with a blank or a piece of stock essentially. So setting the stock boundaries is important because you want the finished part size to meet exact dimensions. So what this program allows you to do is you just simply state how much stock offset you want in each direction. So you have the bottom, the top, and the sides. Ultimately, you'd probably want to leave a little bit of extra stock, so by the time you take your first machining cut, you now have a qualified surface that you can use as a reference.
In this next section here, you have the fixture. And in this part, you just pick all the parts that make up the fixture, and that tells HSM that we're not going to be milling those parts, but they're just there for reference. In case we end up, it looks like we crashed the machine in HSM, we can tell those things before we actually run the CNC. The last thing we want to make sure we have set up in this program is our work coordinate system. Now this is important because when you put this stock blank in the CNC machine doesn't know where the stock part is until you tell it. And so this coordinate system here is what HSM uses to calculate all the tool paths and tell the CNC machine how to cut it out. So when we put the stock in the CNC, we'll set part reference 0 at this coordinate system, and then it'll know exactly how to cut this whole part out. And so you can select top plane, bottom plane, whatever you'd like, and then the different corners of the part, and you can see how it'll move that coordinate system around. So that's a very important thing you want to have set up correctly and know where it is when you plug it in the machine. So once you have all these features set up, you can just hit the green check mark here to accept the changes, and now we got our job completely set up. The next thing we're going to look at is the tool library.
Alright, so we've already set up our part, we've got the geometry figured out, we've got the fixturing figured out. Now it's time to start doing some machining here. So just like in a manual machine tool, you'd have to set up your tools that you're going to use for the various features that you're trying to cut. I'll just go ahead and edit this half-inch flat end mill here just to show you. The first thing you might want to do is just the general tab here, which you get to set the tool number. The machine needs to know where this tool is located so it can find it. And then you have a couple of other features here, like if you want some cooling and what kind of cooling, and then the material that the tool is made out of. You have your usual types here. The next tab is the cutter itself. This is an important tab right here because you get to define the tool's geometry. So right now we said that we have a half-inch diameter end mill. The shaft diameter matches the cutting diameter, shoulder length, all these parameters, so that way it knows what the tool looks like. A very important tab here is the tool type, to where you get to pick all the common tools that you have, whether it's a drill, a flat mill, bull nose, etc. And then finally, the feeds and speed tab here is incredibly important. So the way you would set this is, if you know, for example, that you're cutting aluminum, 700 surface feet per minute might be a reasonable speed, and then you get to set your feet per tooth right here. This is how much you're taking off per tooth, and it matters to set the number of flutes that you have. So once this is all configured, the machine can automatically determine the spindle speed and the cutting feed rate that you would want just by simply setting these parameters.
Once you have all these parameters set up, you can click OK to accept the tool. And we already have all the tools set up in this program just to save a little bit of time in our presentation. So click OK to exit out of that. Now the first thing we're going to do is we're going to face off the stock to get it down to the part size. And that's this feature right here. Now I'm just going to delete this and then create a new one just so you guys can see the whole process. So we come up to 2D milling and we click face. Now this brings up the face editing toolbar over here. The first thing we want to do is select the correct tool. So I'm going to click library. Now I'm going to come in and select this 3-inch face mill. Click select. So that pulls the tool in, as well as all the spindle speed, surface speed, things like that the machine needs to know in order to use that tool. The second tab here is the contour that we're going to cut on. Now HSM knows that for facing we want to use the stock size initially to face down to the size of the part. You can see that's the orange box right here. So we're going to leave that. Oops, I didn't want to exit out of that quite yet. Get back in there. So we're going to come over to these clearance planes and heights. So the clearance height is the height that the machine knows it can go to, and it will still not collide with anything. So we're going to set that to, you can click this down menu and you can click all these different properties. I usually do from stock top, so that's the top of the stock, and then we're going to put it at 0.4 inches above that. So you can see that's this plane right here. And so we know that the machine won't collide with anything if it goes to that plane. This retract height is the height that the machine knows it won't hit anything when going from one feature to another. So say you're drilling these two holes. If I put in a retract height of 0.2 from stock top, the machine will come up to 0.2 above the stock, move over, and then start drilling again. That's not really relevant for this this operation, but I just wanted to talk about it now. The feed height is the plane from where the machine will start feeding the tool in to cut the face. And so we set that from top 0.2 inches, so you can see that's this plane right here. And these are very important because it keeps the machine from colliding with anything while it's cutting out the part. The next section is the top right here. So this is the top of where it's going to start cutting. And so we want to start from the stock top 0 inches. We know that's the exact point of the stock top. And then we're going to cut down to the model top. And HSM knows where all those features are, and so we don't have to plug in any dimensions for those. Next, we're going to come over to this Passes tab. And you'll see in future operations there's tons of things you can change in some of these, and we just don't have time to go over them. But I'm going to go through some of the basics here. This box here is your step over box. And what that is, we know the cutter head is 3 inches in diameter. And so we want to set the step over to a little bit less than that. We set it to 0.285 inches. And that'll make sure that the cutter head is always stepping over into some of its own cuts, so that we won't be leaving any ridges or anything like that on while it's facing. This right here is the pass extension. So if you want the cutter head to go past the stock size a little ways, again to make sure it doesn't leave any ridges or any uncut areas, you can increase that value. Everything else we're going to leave. I am going to select this multiple depths here. We have 40 thousandths of material we need to cut off before we get to the part top. And I'm going to leave it at that. That's a acceptable cut depth right there. But I want to click on this finishing step. This finishing step will run one more cut path at a very shallow depth in order to give you a real nice finish. So I set that at 3 thousandths of an inch. The last part here is the direction. See if I can get that little window to come up again. Explains it better than I can. Conventional milling, I like to think about this in the sense of a car basically. And so conventional milling, your wheels are turning one way, but the cutter head is going to be moving in the opposite direction that the wheels are moving, as you can see there. It doesn't really make sense as far as a car goes. But climb milling, the cutter head's going to be turning in the same direction that the mill head will be moving. Climb milling will leave a better finish on the part, but we're not going to worry about that too much when you're facing. That's going to be more when you're contouring. So we're going to leave it at both ways. So it'll do conventional and climb milling, and you'll see when we accept this, it'll kind of do a zigzag pattern. The last thing we're going to do is we're going to come over to linking. And a lot of this stuff we just leave as is. Rapid retract, that's where the cutter head will retract to the clearance plane before the machine will start to move. Keep tool down. These are different things that you can change when you're doing multiple cuts inside of one feature. So we actually don't have to worry about that now. This last box here, leads and transitions. So this is the lead in and lead out, and that's how the machine's going to enter and exit the stock as it's cutting. Generally it knows what it's doing, and so we can leave those as is. So when you're finished setting up all these parameters, I know there's a lot, we'll get through it, but you can hit this green check mark and it'll start to create the tool path. So you can see with these arrows, this is where the tool will come down. It's going to come across the top here, cut that way, and then it'll turn around, cut back this way, and then your exit will leave right there. I'm going to move this just to the top here so we have it in the correct spot.
Okay, so we faced our part. Now we're going to get into some different types of operations here. A really unique one that comes in this package is this 2D adaptive clearing. So I'm just going to click on it here. You can see the tool path. There's a whole lot going on with it. Let's look a little more into the situation here. Just going to go ahead and hit this edit tab. So just like before with any process, you have to pick a tool type. We picked this 1/2 inch end mill here to do the job, so you can make it inside of these radii right here. And it's the usual selection process. I'm just going to kind of burn through that since we've already touched on it. Okay, so moving on to the selection process. So this is the familiar window here, the blue window, where you get to pick your contours. And the area you see highlighted in blue is what we picked for this geometry. And an important thing is that it already knows where the stock is, and by the nature of this 2D adaptive clearing process, it knows that we're looking to remove the material that's between this. We're just roughing out a lot of material to get the general shape of the part down. Moving on to the next tab, this is all stuff we've already touched on. Just like before, it needs to avoid collisions and interference, so you got to set all these parameters up. Alright, so let's move into this tab here. A very important aspect of this is, like I mentioned before, this is just a roughing process. So we want to leave a little bit of stock. We don't want to cut to the finished size, so that way we can come back with a contour pass and give ourselves that nice finish that we want. We want to check multiple depths, so that way we avoid taking off too much in one bite. You want to have a good amount of chip load on the tooth. And then finally, there's this little radius tab here. So what that does for you is that, say you have a really large cutter and you're trying to get a sharp corner, it's going to make sure that it doesn't dig into that. If it can't reach it without crossing the lines, it's not going to. Just like when you're coloring in a coloring book, you want to stay in the lines. So that does that for you, so you can always come back later with a finer tip tool and get rid of what you couldn't get with a larger tool. The linking parameters is a lot of the same stuff we've already covered. And since we're running low on time, I'm just going to go ahead and hit the green check here and show you the result. So this essentially generates a tool path on its own with the goal of removing as much material as possible a lot faster than you would with, say, just an offset where it would go around and around, or a zigzag. It just kind of generates an automated tool path. These yellow lines show where it just kind of lifts up and it comes clear across the part into this other region here, and it does a bunch of stuff, and then it does it again over here. So it just kind of takes over and generates a tool path all on its own. So one last thing that we should probably talk about. Now there's a lot of CAM packages out there and they all pretty much do this sort of thing. But one thing that at least I found really cool about this particular package is the ease in which you can accommodate design changes. So for example, we have this part right here that we made, and because it's already in the SolidWorks environment, you can do something like come over to your part under this the regular modeling tab, and say we want to change a dimension here. We want to change this height from 1 inch to 1 1/4. So we could just do that as usual in the SolidWorks, and of course we'll have to regenerate the part. But now when we go back to our CAM tab over here, what's really neat is that at first all these tool paths, of course they're broken links, they need to be updated, but with just a simple click we can regenerate all these tool paths right here, and it updates that contour geometry around the outside or whatever else we might have done. So you know, that's a pretty powerful tool in itself.
Now I know we haven't covered everything in this tutorial here. There's a lot more you can do with this program, and it really is pretty sweet. But we got to finish out with the time that we have allotted. So thanks for watching our video. Have a great day.